Kia ora koutou. In this video lesson, we are going to be going over a triangle task involving points A, B, and C. So first off, we plot A, B, and C in the plane. Always a good idea to put a little zero around the origin where the x-axis and the y-axis meet. Okay, first off, we're going to find the midpoint of A to B. A is -3, 2, and B is 4, 5. When we're finding that midpoint, all we're doing is averaging the x values. -3 plus 4 is 1. Cut that in half, we get 1/2. Same thing for the y values. 5 plus 2 is 7. Cut it in half, 3.5. So the midpoint of A to B is 1/2, 3.5. Next one, we're looking for the midpoint of AC. A to C, A is again -3, 2, and C is 2, 0. We average the x's. -3 plus 2 is -1. Half of that is -1/2. And then average the y values. -2 plus 0 is 2. Cut it in half, we get 1. And there's the midpoint, -1/2, 2. And lastly, the midpoint of BC. In between 4 and 2 is the number 3. 4 plus 2 is 6. Cut it in half, we get 3. 5 plus 0 is 5. Cut it in half, 2.5. So 3, 2.5, that would be the midpoint there. Any one midpoint is enough to work towards achieved. Next, we're going to be looking at the gradient of A to B. Now the gradient we know is the rise over the run to the right from A to B. There is A, there is B. I went up 3 and over 7. That's the gradient. Okay? If you want to use the formula, it was from A to B, 5 minus 2 over 4 minus -3, right there, so 3 over 7. I have found a lot of you saying drawing a little triangles is much easier to get gradient. Okay, now from A to C. A to C, we notice that line goes down to the right, so that number is going to be negative. Down 2, 5 to the right, -2 over 5 is the gradient. Lastly, B to C, we've got, well, since it goes up to the right, you want to really say C to B. Just like you read a sentence from left to right, you look at one point to the next from left to right. So, first, how many up? 5 up, 2 to the right. So 5 over 2 was the gradient for B to C. Now you can use those same numbers, this 2, 3, 7, 2, and 5. You can use those for the next part, which is going to be the distance or length of a line segment. So from A to B, we're going to be using the theorem of Pythagoras, te ture, O Pythagoras. So from A to B, up 3 over 7, it's going to be a squared plus b squared, square root of it. 3 squared is 9, 7 squared 49, 9 plus 49, 58. AB, the distance, is square root 58. Now from A to C, -2 squared is 4, 5 squared 25, 4 plus 25 square root 29. From B to C, 2 squared 4, 5 squared 25, also root 29. We see two sides are the same length. That means we've got an isosceles triangle. Now we want to see if there's a right angle. It looks like there might be a right angle where AC and BC meet. What you're going to do, take the gradients of those two and times them together. If you need to, whakamahia he ta ta ta, use a calculator if you need to. Those gradients multiply to -1. Therefore, AC is perpendicular to BC. We have an isosceles right angle triangle. There's your merit for the assessment. Lastly, you want to calculate or find out the equation of the line, y equals mx plus c. That is the form of the equation we're looking to get. Now, since we know one point on the line, and I know the gradient, we want the equation for A to B. I know the gradient of AB was 3 over 7. And just because I like to work with positive numbers, I could use -3, 2. I'm going to use 4, 5 because they're positive numbers. We're going to substitute those into the slope-intercept form, where the 4 is x1, the 5 is y1, and the gradient m is 3 over 7. So y minus y1 becomes y minus 5 equals the gradient m times x minus x1. x1 was 4. Brackets mean multiply. 3/7 times x is 3/7 x. 3/7 times -4, -12/7. Now since the equation needs to begin y equals, I need to get rid of that -5. I'm going to get rid of the -5 by adding 5. So it's going to be -12/7 plus 5. Well, since we're dealing with sevenths, and this is 5 over 1, we want to change this 5 to having a denominator of 7. 7 times 5 is 35, so negative 12 sevenths plus 35 sevenths is positive 23 sevenths, and there is the equation of our line. There is your excellence. Any patai, send them my way. Just want to leave you with this. You do need to know the types of triangles, a little refresher there. If 3 sides are the same length, that is known as an equilateral triangle or an equiangular triangle, where all sides are the same length, all angles the same measure, 60 degrees per angle. If 2 sides of your triangle are the same length, that's an isosceles triangle, and if no sides are the same length, that is a scalene triangle. Maori mahi, maori ora, ka kite ano.